composite functions. This is when we do something like f of g of x. We will either denote this with a little open circle, or a little more logically, we can put g of x where x goes in f of x. This is different than f times g because we are plugging g into the function f. We are using the output of g as the input of f. In other words, we are taking f of x minus 5. We plug in x minus 5 for x, multiply through by 2, and add 1 to get 2x minus 9. We can also find g of f of x, and it will be totally different. We put 2x plus 1 in for x in the g of x expression, and all we need to do is then subtract 5 to get 2x minus 4. But it doesn't end here. We could do f of x and g of x if we wanted. This is not the same thing as squaring the function, which we can also do. F of x would mean plugging in 2x plus 1 where x goes, and that means multiplying through by 2 and then adding 1 to get 4x plus 3. We could do f of x or g of x or any sequence you can imagine using 2 or even more functions.
Now that we've reviewed function composition, let's talk about the notation f of g of x. It represents the composition of the functions f of x and g of x. How do we read this notation? We read it f of g of x. And what does the small circle represent? The small circle represents composition. It means that you take the output of g and use it as the input of f. This notation is called function composition. So let's check your comprehension. Take a minute, or if you're watching the video, pause the video and evaluate the following. F of g of x. So you'll start by taking g of x, which is 2x plus 5, placing it into the function f of x. So where you see an x and f of x, you're going to substitute 2x plus 5. And all you'll have to do is subtract 3. So pause the video, make a selection, and then come back to see if you're correct. All right, let's start here and work from the inside out. So we're going to take g of x, which is 2x plus 5. We're going to plug it in here where we have an x into f of x. So 2x plus 5 minus 3. We can combine these two constants. 5 minus 3 is 2. So simplifying this, you'll get 2x plus 2. The answer is B. Our agenda this week. On Monday, you should go into the course and you should look at your vocabulary study set in Quizlet. If you have not joined Quizlet, everything is there in the announcements, but you have to get into the course and sign up. If you have any trouble at all, you need to let me know. Not everybody has done that, so we're very late in the semester. Please utilize all of the help, all of the tools, all the asynchronous pieces that are available for you. So you should have gone through the introduction to this course by 4 p.m. yesterday. If you haven't, get caught up. Don't get too far behind. If I'm out doing testing at the end of the semester, like I was last year, I will not be available to help you. So we want to stay on track and come in for help anytime you don't understand something. Office hours are at 10 a.m. They're in the course content under resources, under material. You can drop in on Monday and on Thursday at 10 a.m. to ask quick questions, especially if you have grading questions. That's a good place to come. And then we have help sessions on Tuesday, Wednesday, and Thursday from 4:15 to 5. We also have small group on Friday. If you're not mastering something, if you've tried, I'll pull you in to give you some extra help then. All right, so review your vocabulary in Quizlet prior to class. We're going to be starting Unit 4. So if you have not completed Unit 3, especially those unit tests, do that. Don't wait any longer. All right, so this is our link to our study set. We're going to be looking at logarithms and exponents, starting with exponents. So that's where our focus is going to be today. Now, I looked this morning, and there were only 3 students out of over 200 who've even looked at that. I know who you are. Those of you that are doing that preparation on Monday or prior to class, you're going to be coming to class with the tools that you need in order to communicate effectively. All right, so let's look up the word exponent. So when I say look up, most students are going to Google it. What I want you to do is look up in a mathematical site, because these words can have more than one meaning. So the best place to look is in Quizlet. If you're not part of my Quizlet class, and you haven't been using this, you're at a disadvantage. All right, so how would you tell an 11-year-old what an exponent is? We have a visual. So if you write a number, this is the base, sitting on the ground. The exponent is going to be raised up higher. It's a power. Okay, we think of power as being up. All right, so this is our exponent. What it means is we take our base and we multiply it to itself that number of times. So use the words that a 12-year-old would understand. And then you start building on that and bring your vocabulary into class at the high school level, not a college level, high school level. So let's move on to the inverse of a function. That should be in your study set as well. If you've looked at that prior to class, this should go very quickly. All right, an inverse of a function is something that undoes another function. So we're going to be doing the opposite. So let's write down the steps, a quick review, and use these as you work through Unit 4, Lesson 2. Step 1, we're going to rewrite f of x, putting a y in for f of x. So our equation will look like y equals something. And then we're going to swap the x's and the y's. And then finally, the last step is to solve for y. Get y by itself. All right, our objective for today, or another way to look at that is our target, is to graph exponential functions. In order to do that, we need to be able to generate and solve exponential equations. All right, today I am generating and graphing exponential equations so that I can solve and graph exponential equations. I'll know I've got it if I can complete the exit ticket. But that's not enough. You need to get into the course, start taking notes in your own handwriting, because we have the last unit, and you know notes are extra credit. And I do not take type notes unless you've spoken to me about that first. We're going to start with the inverse of f of x equals x squared minus 4, and the domain on which the function is invertible. Now this may take a little bit of time to sink in. So we're going to work through this in class, but go through and take notes and do all the practice. Every day you should go in and practice until this sinks in and you get better at it. It's not going to be easy the first time you see it. So don't just do it. Go into math once a week and get it done. You're not going to end up understanding enough, and it'll make it a little more difficult. So practice, practice, practice. All right, we're going to start with x squared minus 4. Now, if we take that minus 4 and don't look at that and just look at y equals x squared, I know it's a parabola, and it's going to look like this. It's going to cross through the origin. But if I subtract 4, notice what's happening. It's going to go down 4 units. It's going to start here instead of the origin. So we're going to look at why that happens and what those rules are briefly, and we're going to put them into play. But let's start with inverting this. Before we do, let's talk about the domain. If you recall in Unit 1, we knew that this was a function with a vertical line test. Every time you draw a vertical line in this function, it's only going to cross at one point. There's only going to have one y for each x. So when we invert this, we're going to replace f of x with the y. So we're going to take this. We've already done that here. And then we're going to swap the x and the y. So where I have a y, I'm going to put x. I'm going to put a y here equals y squared minus 4. So that's what I have here. All right, this should not be an x right here. I'm sorry, that was my mistake. Let's take that off. So y squared minus 4. Now we're going to solve for y. All right, so I'm going to add 4 to both sides. So we'll have y squared equals x plus 4. So this should be plus 4. Take the square root. So y equals the square root of x plus 4. Now I'm only taking the positive, and you'll understand this better when you get into the content and you do the practice, why I'm only taking the positive. All right, when you graph this, we're going to do a horizontal line test. So when you invert a function, everything is going to become the opposite. So instead of a vertical line test for every y, there's only one x. All right, let's look at exponents. We know how to do this. 3 squared is equal to 3 multiplied to itself 2 times. So 3 times 3 is 9. And let's go down here. You know how to do this. 3 to a rational exponent. The top number is going to be the power, and the bottom number is going to be the root. This number is always our base. So let's just look at the left-hand side, and let's write that as 3, take the base, to the first power, and it's going to be under the root of 2. That's a square root. So we write that as square root of 3. So now these two things look alike, don't they? Now today we're going to learn how to do this and more. All right, so now we've got a fraction. So this is 1 over 32. Remember, the top number is the power. So this is 1 over 32 to the third power. And we're going to take a root of 2. That's a square root. So this is how you write it. Now we can simplify this. So we're going to go ahead and take 1 to the third power is 1 times 1 times 1 is 1. And then 32 to the third power, I'm just going to go ahead and write it out 3 times. 32 times 32, so I don't have to factor it out here in a minute, times 32. Now that's all under a square root, so I can pull that square root into the denominator and the numerator, and then simplify these individually. So the square root of 1, I'm going to move up here to the top where I have more room. Square root of 1 is 1, and the square root of 32 cubed. Now I can take out a pair of 32s, but we have one that stays under the radical. Now we're not done yet because we can't have a radical in the denominator, so I've got to multiply by the square root of 32 over the square root of 32. Now we can have a radical in the numerator, so the square root of 32 times 1, that's okay. On the bottom, we already have a 32. Now when we take the square root of 32 times the square root of 32, that's undoing. That's the inverse. We're multiplying. So we have the square root of 32 squared just becomes 32. We're almost there. 32 times 32 is equal to 1024. So we have 1024 in the denominator. And in the numerator, we have the square root of 32. So this is our answer if you were to simplify it. All right, now let me walk you through this. Now remember to go back to Quizlet. It has all of your exponent rules. Next week when we go into logarithms, you need to be familiar with exponents so we can build on them. So practice, practice, practice. All right, we don't have the same base, but I can look at 4 and I can rewrite that as 2 squared. So 2 squared to the 1/3 power. When you have a power raised to a power, we multiply. So this is 2 to the 2/3. And we already have a 2 to the 2/3. Okay, so now we are multiplying. We have the same base. The rule says that we add the exponents. So this is 2 to the 2/3 plus 2/3. So this is 2 to the 4/3. Now if you were going to write that, it would be 2 to the 4th power under a root of 3, or a cube root. Let me move up here to the top, expand that out. So we have a cube root of 2 times 2 times 2 times 2. So we can take these out in multiples of 3. So we've got a 2 that comes out, and we have one lonely 2 that stays in. So we have 2 times the cube root of 2. All right, this is our answer. All right, so one of the things that you should have recognized that you learned in middle school and again in algebra is when we have the same base, we add the exponents. So we had to create the same base. If possible, then we can add the exponents, but we have to have the same base. So looking at that example, let's try to get these two things as the same base. Now I recognize that 16 is equal to 4 times 4. Okay, I don't need to bring that down to a base of 2, even though you could, but let's keep it as 4 squared. 16 is 4 squared. we're raising 16 to the 2/3 power. Okay. And on the bottom, we already have 4. We're going to keep it as 4. Don't change it. 4 to the 3/4 to the 1/3. All right, now same base, raising a power to a power, we multiply. Okay, so that's going to be 2 times 2/3 is 4 to the 4/3. On the bottom, we're raising a power to a power, same thing. So we're going to multiply exponents. Multiplying 3/4 to 1/3, the 3's cancel, so we're left with 4 to the 1/4. All right, this is very much like this, except we are dividing, not multiplying. When we multiply, we add. So predict, what would we do if we're dividing? Yes, we would subtract. So this is going to be 4 to the 4/3 minus 1/4. You subtract the exponents. Now here's my little trick for subtracting or adding fractions that are simple, small, that don't have the same denominator. I use butterfly arithmetic. Okay, I make my wings and I go from bottom to top. 4 times 4 is 16. 3 times 1 is 3. 16, don't forget we're subtracting. 16 minus 3 is 13. And let's make that tail here at the bottom. 3 times 4 is 12. All right, so 4/3 minus 1/4 is 13/12. So this is 4 to the 13 over 12. Now if we wanted to work on simplifying that, we would take 4. Remember, this is to the 13th power. And we're going to take the root. This is the power on top, the root on the bottom. So we're taking a 12th root. And I'm not going to write out 13 of these. But if I did write it out, expand it to 13, and I took 12 out, I would have 1 remaining under the radical. And then I'd take out that group of 12 and I'd put 1 outside of the radical. So this would be 4 12th roots of 4. All right, so for each of these, tell me whether you're going to add, subtract, or multiply your exponents. All right, same base. Same base, the base is 3x. So what would we do with the exponents? Multiplying, we add. Same base. Dividing, we subtract. So this would be 3x to the 2 minus 5. This is going to be 3x to the 2 plus 5. All right, what about same base, m? We're dividing, so we're going to subtract. So this would be m to the 2 minus 1/3. I'm not going to follow through and simplify that. I'm just going to show you what direction we're going in. Multiplying, same base, you add. All right, now this is not subtraction because we have 8 to the 3/8 raised to the power of 2. This is multiplying. So this would be 8 to the 3/8 times 2 would be 6/8. You'd simplify that. That would be 8 to the 3/4 power. All right, again here, a power raised to a power, we're going to multiply. So this would be 125 to the 6 over 3. Simplify that. 6 over 3 is 2. So that would just be 125 squared. All right, now we're going to do this together. We're going to find the solution to this equation. So let's start off with the same base, and I can see we're going in the direction of base 2. So this is 2 squared to the, I should have written it like this so it was more clear. It's really hard to type in mathematical terms. So this is 2 squared times 1/2 plus 2x is equal to, now remember, we can pull this out and write this as the root is 2 and it's 2 to the first power. So that's 2 to the 1/2. Now let's go ahead and raise this power to the power. So we would multiply, distribute through. 2 times 1/2 is 1, or 2 divided by 2 is 1, plus 2 times 2x is 4x. So this is 2 to the 1 plus 4x equals to 2 to the 1/2. Now if we have the same base, here's where you get your equation. The powers have to be equal. So our equation is 1 plus 4x is equal to 1/2. Start by subtracting 1 from both sides, and you get 4x is equal to 1/2 minus 1 is negative 1/2. And then you divide by 4, which is the same thing as multiplying times 1/4. And so you would get x equals negative 1/8. Now I have to skip some steps because my board's not really big. So make sure that you are writing down all those steps if you're taking notes. So now it's up to you to find the solution to this equation. So pause the video and see if you can work this out the way that we worked out this equation. All right, so now we're going to come back and check your work. So remember, we've got to start off with the same base. So I'm going to write 9 as 3 squared. And we're raising 9. Again, I should have written this more clearly, but it's so hard to type, so I forget sometimes. So this is 9 to the 1/3 plus 4x. Now we're going to write the square root of 3 as 3 to the 1/2. Now let's go ahead and raise this power to this power. So you've got to distribute that 2 to the 1/3 and to the 4x. So this is 3 to the 2/3 plus 8x. That's equal to 3 to the 1/2. So now that we have the same base, our exponents must be equal. That's how you set up your equation. So you set it up as 2/3 plus 8x equals 1/2. All right, now we're going to subtract 2/3 from both sides. This is going to be 0. We're left with 8x equals, let me do my quick butterfly math. 3 times 1, go from bottom to top, is 3, and 2 times 2 is 4. We're going to subtract, that's in the middle, and then we'll multiply the tail to get the denominator. So let's get the denominator first. 2 times 3 is 6. We already multiplied 3 minus 4 is negative 1. So 8x is equal to negative 1/6. The last thing we're going to do is divide by 8. Another way to look at that is multiply by 1/8. Okay, so that cancels and we get our answer. X is equal to negative 1/48. All right, here's an example why this is an exponential equation. It shows growth. You'll show decay when you have a rational power. Okay, that just means that the graph is going to go in the opposite direction. Instead of starting down and going up, it's going to start up and go down. We don't have a lot of time to show that here, but let's just run through this quickly and you go through the course content and do the practice. And pay attention, take more notes when you come to growth and decay. So what I did is I picked out some numbers for X and for Y. I picked out 2 or 3 negatives. Always pick out 0 because that's easy. Anything to the 0 power is equal to 1. So we know that when X is 0, right here, Y is going to equal to 1 in this simple type of equation. All right, so there's your y-intercept. The domain is anything that x can be, and x can be any number from negative infinity to positive infinity. But the range with this type of equation is always going to be your x-axis. So we'll start at 0 and we'll go up to infinity. All right, your horizontal asymptote, remember, is always going to be y equals 0. That's your x-axis. We don't have a vertical asymptote. So let's try to see if we can do this. I think I've got these backward. All right, the red line is y equals 2 to the x. Okay, so this is just a simple, what we looked at before, exponential function. So the asymptote is always going to be at y equals 0, or the x-axis. We don't have a vertical asymptote. X can be anything, and y is going to start at 0. It's not going to go down below the x-axis. So let's see if we can take this equation. It's going to be the blue line where we move it up 4. Okay, it shifts up 4. So you can see now that the asymptote is going to change to, if we started out here at 1 and we added 4, it's going to be at y equals 5. Some quick things to pay attention to. It's also going to be continuous and increasing. The y-intercept is at 0, 5, because we just add 4 to that y value. Okay, the range is now going to be from, let's see, where is that asymptote? It's at 4 to infinity. The domain is still going to be, x can be, remember the domain is what can your x's be? Can be anything negative or positive. And that's it. I think we've got everything here. So let's just go through this quickly. Vertical shifts, you saw that when we start off with an exponential function and we add to it, we're going to go up that many units. When we subtract, we're going to shift down that many units. Stretches happen if we multiply our function, some exponential function, by a value. So when we multiply by a number such as 2, it's going to look like this. Now this is just a brief introduction. Make sure you're going through the course content so you can see it and practice it better. Okay, so it's going to stretch it in. It's going to squeeze it in. When we multiply by a fraction, it's going to flatten it out. So if our original function goes like this, it's going to flatten out more. If you multiply by a whole number, it's going to squeeze it in closer to the y-axis. Now horizontal shifts if we add or subtract a number in the exponent. So we take the exponent and we add 2. Let's just use 2 as an example, or subtract 2. It's going to shift it horizontally to the left or to the right. Okay, a brief introduction. All right, let's watch this video and then we'll come back and discuss. All right, this is going to take about 5.5 minutes.
In this video, we're going to look at two different examples of graphing an exponential function and its asymptote in the form f of x equals a times b to the x. In this first example, we have y equals 4 times 2 to the x power. This 4 out in front is a stretch factor. It's a vertical stretch factor. The 2 is our base. And the asymptote of this function, the asymptote of any function in this form, is going to be at the x-axis. So I'm going to go ahead and put that on my graph to begin with. So my function is going to get infinitesimally close to the x-axis, but it is never, ever, ever going to touch it or cross it. So here's the method that we're going to use to figure this out. We're going to start with x values, and I picked 2 negative, 0, and 2 positive values. We are going to calculate our y values, and we will create ordered pairs x, y. From those, we'll put them on the graph, and we will connect them. So we'll start by plugging in -2, and that gives us 4 times 2 to the -2 power, which is 4 times 1 over 4, which is 1. We plug in -1, we have 4 times 2 to the -1 power, which is 4 times 1/2, which is 2. We plug in 0, we have 4 times 2 to the 0, which is 4 times 1, which is 4. We plug in 1, we have 4 times 2 to the first power, which is 4 times 2, which is 8. And if we plug in 2, we have 4 times 2 squared, which is 4 times 4, which is 16. To create our ordered pairs, we have the ordered pair -2, 1. We have -1, 2. We have 0, 4. We have 1, 8, and we have 2, 16. I'm going to go ahead and put all those on the graph. We have -2, 1. We have -1, 2, 0, 4, 1, 8, and 2, 16. And the last step is to connect those into our graph. Again, we're going to get really close to that asymptote, but we're never going to cross it or touch it. And there's our graph of y equals 4 times 2 to the x power. For the second example, I'd like you to pause the video here and try to graph 3 times 1/2 to the x power on your own, and then resume the video to see the solution. Welcome back. Let's see how you did. Again, we are going to take our x values that I've identified, 2 negative, 0, and 2 positive values, and we will use those to calculate our y values. If x is -2, y is 3 times 1/2 to the -2 power, which is 3 times 4, which is 12. If x is -1, we have 3 times 1/2 to the -1 power, which is 3 times 2, which is 6. If x is 0, we have 3 times 1/2 to the 0 power, which is 3 times 1, or 3. If x is 1, we have 3 times 1/2 to the first power, which is 3 times 1/2, which is 3/2. And if x is 2, we have 3 times 1/2 squared, which is 3 times 1/4, which is 3/4. To create our ordered pairs, we have -2, 12. We have -1, 6, 0, 3, 1, 3/2, and 2 3/4. Before we put those on our graph, let's get our asymptote on our graph. Any function in this form has an asymptote at the x-axis, so we'll put that on. We put it on as a dashed line because it's not actually part of the graph, it's a guideline for our graph. And we'll put our ordered pairs on. -212, -1 6, 0 3, 1 3/2, and 2 3/4. The last thing we will do is we will connect all of those points to create our exponential decay curve. As x goes towards infinity, we're going to get closer and closer and closer to that asymptote without crossing it or touching it. And that is the graph of y equals 3 times 1/2 to the x power.
Now that you've watched the video and taken notes, choose the correct graph of the exponential function f of x equals 4.2 times 4.1 to the x. Think about what we're doing. Think about where the asymptote is. We can eliminate a because the asymptote with this type of function is going to be the x-axis. Okay, so both of these have the x-axis as an asymptote. But as you saw and you practiced, this is going to be growth. So it's going to go up in this direction. It's not going to be starting and dropping down. It doesn't have to do with the negative here. Okay, that's not going to give us a descending function. So the answer is going to be C. You can look at the asymptote, eliminate this one. Know that it is just a straightforward exponential function. All right, with this one, let's look at the asymptote again. We're not adding to it. We're not adding anything to the exponent. We're not multiplying. It's just a straightforward function. This time it is descending, but notice we're starting off with the fraction. So this is going to be 3. Let's suppose that x is 2. This would be 3 squared over 5 squared. Okay, so that's what gives us a descending function, not a negative number. But let's look at the asymptote. The asymptote is going to be the x-axis, so this is out and this is out. So very straightforward. This is the function. All right, reflect on your thinking. What were the strategies and skills effective for this assignment? We know that we need to know our rules for exponents. We need to know about what our asymptotes do. Practice what causes a stretch, a vertical shift, and a horizontal shift. Practice until you see it. Okay, when it's new, you need to practice. All right, talk about what you know about asymptotes, stretches, vertical, and horizontal shifts. Make sure you're taking clear notes. All right, so the next steps, finish up any course material for sections 4.01 and 4.02. Don't just work out of your plan. Go into the announcements daily. Go into the course and practice 30 to 60 minutes every day for math. Look in the material in the I Can. Start taking notes if you haven't already. All right, extra credit only opens up for a week after that unit closes. So if you're planning on turning in notes for extra credit for Unit 3, that's going to close on Thursday. No type notes without getting permission first. It's really hard for me to grade, guys. It's really hard to type. If you haven't completed your Unit 3 test, do it now. Even don't let fear keep you from trying. I can't help you if you don't try. All right, so make sure you know where the I Can is and use that material there. If there's something that you need but you don't see it, let me know. I'll try to get the support that you need. But don't get behind. This is your last unit and you must try. Notice that I have a new phone number, so you need to go into each of your teachers' contact information in the course to find the new numbers. Everybody got a new number and we began using it about a week or maybe 2 weeks ago. All right, extra credit is detailed handwritten notes. You're only allowed one submission. Use Genius Scan or CAM Scanner, but please stop taking pictures and turning them in. I will grade them. I'll do everything I can do to grade them. But when you're, at the end of the semester, at the end of the unit, and you keep coming to me and saying, grade it, and you haven't turned it in as a PDF, it's going to take me a lot longer. So again, you can use your notes while taking quizzes or tests. So notes are helpful. Don't avoid doing that. And use Quizlet. That's an organized place for you to have notes if you have fallen behind. All right, my tips. Make a folder on your desktop called Pre-Calculus. Create a folder inside that folder called Unit 4 Extra Credit, or whatever you're doing, whatever assignment you're doing. Save all scans, pictures of your notes into that folder, and at the end, you can zip it. I prefer it not to be zipped. I prefer for you to use Genius Scan and just simply take pictures as you would on your phone, but it converts it to a PDF that's very clear and easy for me to read. So let's forget about the zip folder. That's causing some confusion. Just use Genius Scan. Go to your course homepage, click on Tools, click on Assignments, and drop that extra credit, those submissions into that drop box. All right, so I cannot stress this enough. This is really slowing me down on grading, and then y'all send me emails saying, grade it. I'm going as fast as I can. Extra credit for Unit 3 is going to close on Thursday or Wednesday at midnight. All right, here's our exit ticket. Scan this in and complete the exit ticket. If you have any trouble with the exit ticket, let me know.